Hello guys, welcome back to the channel. Today we're going to solve this Leetcode question, which is pass the pillow. So basically in this question we are given n people standing in a line labeled from 1 to n. The first person in the line is holding a pillow initially. Every second the person holding the pillow passes it to the next person standing in the line. Once the pillow reaches the end of the line, the direction changes and people continue passing the pillow in the opposite direction. For example, okay, I'll explain you with this diagram. So basically we have n people, and in the hands of the first person there is a pillow, and we're given a time as well. So at every second each person passes the pillow to the next person like this, and when the pillow reaches to the last person, he'll again pass it to the previous person. So what we need to do is we need to tell where the pillow will end when the time becomes 0, right? So initially we have n equals to 4 people and we have time 5 seconds of time. So initially the pillow is at this guy, and at the next second he will pass it to this fellow, and then this guy passes the pillow to this guy, and this guy passes the pillow to this guy. So basically we have 5 seconds, right? 5 seconds. So it will take 1 second, this will take the second, this will take the third second, and then again this guy passes the pillow to this guy, and again this guy passes the pillow to this guy. So it will be 4 and 5. At the 5th second, when the 5th second finishes, the pillow will end up at this guy, right? So when we label these people as 1, 2, 3, 4, the pillow had stopped at the person 2, right? So the answer is 2. And so basically that's it. You get the idea. You got the idea, right? So how are we going to solve this question? I'm sorry, I removed his head. Now how are we going to solve this question means, so basically I'll do the same thing. What I'm going to do is I'll take a pointer I starting from 1, and I'll take a direction variable called direction. This is the brute force solution that I'm saying. So the direction is 1. 1 means, when the direction is 1 means it is going in this direction basically. And when the direction is -1, it is going in this direction. So I'm going to use this variable in order to determine the direction, and I'm going to make this is the pointer. I equals to 1 means it is pointing to the first person, I equals to 2 means it is pointing to this person, and this and this and so on. So what I'm going to do is, until my time becomes 0, initially my time is 5, right? And my eye is pointing to this person. Now what I'm going to do is I'll check the direction. Direction is 1, so I need to move in this direction, right? So I'll increase the I comes here and time becomes 4, right? And again the direction is 1 itself, still 1, so this moves here and the time becomes 3, and direction is again 1, so this moves here, I will come here, and my time will become 2. When my eye reaches the end, when my pillow reaches the end, this person needs to transfer the pillow to this fellow, right? So at this point, when the eye reaches the last person, I'll change the direction to -1, right? Now I'm here, right? So I'll check the direction. The direction is -1, right? So when it's -1, I'll move my eye, I'll reduce my eye. Initially here I is 4, right? I'll reduce my eye. My eye will come here and the time will become 1. And when I'm here, I'll reduce the eye since the direction is -1. So my eye will come here and my time will become 0. And I cannot move any further, right? because the time became 0. So I have no more time left, and this the pillow stopped at this guy, so he is the answer. So let's try to code this up. So initially, as I said, I starts from 1. The direction is also 1, right? Now, while my time is greater than 0, what I will do is, if my direction is 1, I'll increase my I. Else, if my direction is not equal to 1, I'll decrease my I, right? And when I reaches n, when I reaches the last person, I need to change the direction to negative. And when I reaches the first person, the direction needs to change to 1, right? Because we need to transfer in this direction. So when I reaches n, when I reaches this guy, the direction becomes -1. And when I reaches 1, the direction becomes 1, right? At every step my time will reduce, right? And at the end I just need to return the I. And oops, there's now when we run this, it's getting accepted, guys, but if you observe carefully, what is the time complexity here? The time complexity is order of time. If the time is 10, we're moving 10 times. Our loop is dependent on time, right? So if the time is 10, we will be moving 10 steps. If the time is 100, we'll be moving 100 steps. So if the time is 1000, we'll be moving 1000 steps. So the time complexity is order of time. The space complexity is order of 1. Since we aren't using any extra space, the time complexity, the space complexity is order of 1. So okay, let's try to reduce the time complexity. So if you observe carefully, let's do one observation. Let's say we have 10 persons. So let's observe this example and we'll try to find an observation. So basically we have 10 people. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now initially the pillow is at the initial guy, right? And at the first second I'll be here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? Let's say our time is 20. When the time is 20, at 18 seconds we are here. We are again here. We went till the end, and we again came back to the beginning, right? So at this point we finished 18 steps, and this will be 19, this will be 20. So at the end the pillow is with this guy, right? Let's say the time is 40. Let's say the time is 40. So initially with 18 steps we'll be here, and again we'll do another 18 steps. It will be 36 steps. Again we'll be here. Again from here we have 4 more steps. 1, 2, 3 and 4. So at the 40th step we came here, right? If you observe carefully, we are basically repeating the same loop again and again. So instead of that, what we can do is we can remove this number of steps. If you observe carefully, from the beginning to ending, suppose if my length is n, I'm taking n minus 1 steps. From the first guy to the last guy, I'm taking n minus 1 steps, and from the last to the first, and I'm again taking n minus 1 steps. So basically when I'm trying to move from first guy to last guy and from last guy to first guy, I'm taking 2n minus 2 steps, because n minus 1 plus n minus 1 is 2n minus 2, right? So from here to here and to here, I'm taking 2n minus 2 steps. So if my time is 100, let's say if my time is 100, basically what I'm doing is, initially for the first 18 steps I came here, and the next 18 steps I again stayed here, and for the next 18 steps I came back to this place, and for the next 18 steps I came here again, and for the next 18 steps I again came here. So now I only have 10 steps remaining, so I cannot come back to this point again, right? So I can reduce these 90 steps, right? There's no point in going from here to here, here to here, here to here, here to here, when the 91 step is from here to here, right? So let's try to reduce the time. So we know that in 2n minus 2 steps we are going to the end and coming back, right? So I'll mod this with 2n minus 2. How does this formula work? So if you observe carefully, n is nothing but 10. 2 into 10 is 20. 20 minus 2 is 18. So 100 minus 18 is, if you Google that, 100 mod 18 is 10, right? So we got 10, which is equals to this one. So we basically, what we're doing is we are just eliminating the loop, that's it, because the length of one loop is 18. 18 is nothing but we derived this with this formula 2n minus 2. How we derive this formula means, from here to here we're taking n minus 1 steps, and from here to here we're again taking n minus 1. So n minus 1 plus n minus 1 equals to 2n minus 2. So we're just reducing these loops. Now again we have 10, right? We have 10 more steps. Now what I'm going to do is, we have 10 steps, right? 10 seconds. We have 10 seconds. Now I'll do another check, because I know that in n minus 1 steps I can come here, right? Suppose if the length is n, in n minus 1 steps I can come here. So if the time remaining is less than the n, I mean the time, suppose if we are here, the time remaining is less than n, that means this is the length of the person, right? So it is n. If it is less than n, that means that the pillow will stay in between these guys, right? So we are not going to go here and we are not going to come back, right? So if the time is less than n, it will be from here in between. So this guy is 1, right? So from this guy I'll just add the time. Suppose the time remaining is 4. 1 plus 4, which is 5. 1 plus 1, 2, 3, 4. This guy is 5, right? So if my time remaining is less than n, I'll just return 1 plus time, because the pillow is starting from this guy and it will be reaching till the time becomes 0. So if we have 4, it will be 1, 2, 3 and 4. And if the time is greater than n, that means I'll go to the end and I'll again start to come back. So I'll reduce n minus 1 from my from my time. That means, Suppose I'm here, suppose if I'm here at time, now I'll take n minus 1 steps to reach here. So I'm just doing that. If I do time equals to time minus n minus 1, that means I am at this point, right? So from here I need to go back, right? So now I will return n minus 10. That means suppose the time is 12. Let's say the time is 12. So it is less than 18, right? 12 is less than 18. So we are not going, we don't have any loops. So the time will remain as it is, and it is greater than n. The n is 10 here. So it is greater than 10, right? So what I'm doing is I'm reducing 12 minus 9. 9 is nothing but n minus 1. So here I have 12 seconds of time. Now when I came here, I only have 3 seconds of time, right? Because I passed the pillow 9 times, right? So from here I have 3 steps, 1, 2 and 3. It is nothing but n is nothing but 10, right? 10 minus 3, which is 7. That is what I'm going to do here. I'm returning n minus 10. So basically we can reduce the time complexity here by, as I already said, I'll reduce my time by time mod 2 into n minus 2. Now if my time is less than n, I'll just return 1 plus time, else I'll reduce my time by time minus n minus 1, and I'll just return n minus time. That's it. We're basically eliminating each and every loop. Output 4. The time is less than n. Time is less than n. Suppose if we have 10 people and we have 9. 1 plus 9. So this okay. This is okay. And here the time is okay. I'm writing n minus 10. Suppose my n is 12 and I have 10 people. N is 12 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Time equals to 10 minus 1. Okay, we are reducing 11 here. Oh wait, 12 minus 10. Oh, we need to do plus 1 here. Yeah. Yeah, that's it guys. So let's look at the time complexity here. The time complexity is order of 1. Since we are not using any sort of loops, this will execute in a constant amount of time, and this all will get executed in constant amount of time, right? The space complexity is also order of 1 since you are not using any extra space. Thank you guys for watching this video. If I made this even more difficult with this diagram, I'm sorry for that. I tried to explain it in an easier way, but I don't know how it went. So thank you.